Hello civil engineers, welcome back to the lecture. So in this lecture, we'll see how to take out the concrete quantity and the shuttering quantity for the slope footing. So far, whatever we saw was for the combined footing, which was rectangular in shape, and the isolated footing, which was either rectangular or square in shape, which was very simple. But how do you find the concrete quantity and the shuttering quantity for such type of footing, which is called as slope footing? Okay. So we'll try to understand. For that, I'll take you to the Excel sheet, what I have created already. See, this is a typical section what you have. Okay, so this is a plan of your footing where the length of your footing is 3.8 meter and the breadth of your footing, okay, this should have been this side. It's okay, not an issue, because this should have been the length and this should have been the breadth. Okay, now I'll do it so that there is no confusion. Yeah, so I'll make this as 2.6 and I'll make this as 3.8. Okay, so this is 3.8. This is the length side and this is 2.6, the breadth side. Okay, and yeah, give me a minute. Yeah, done. Yeah, now it is clear. Yeah, so this is my breadth, which is 2.6, and this is my depth, or let us say the length of the footing, which is 3.8 meter. Okay, fine. Now since it's a slope footing, you can see this is a kind of a slope what has been created. Okay, this is a kind of a slope. In the cross section, you can see this particular slope. You can see this particular slope. This is a slope. Okay, and then after that we have a column in the middle. So this column you can see here. So this is a column which is in the middle here. But from here, this slide from the column outer face to the this outer face, this small gap, no, this gap and this gap. This is that gap, okay? This gap and this gap. This much you are clear? So to put it in a better way, quickly try to understand here. See, this is a slope, this is a slope, and this is that offset portion, this portion and this portion. Your column will come here, but there's small offset here. Similarly, you can see the column is only this much part. The column part is only this much, okay? This much is your column part, okay? But whereas this portion you can see small from here to here, this is that extra portion, this is that extra portion. So in the plan it looks like this, okay? In the cross section it looks like this, in the plan it looks like this much is clear. So first, what quantity I'm supposed to find? First, let me find the PCC quantity for this. So PCC quantity is very simple. I've written it here. Length is 3.8 meter. I'll teach you how to prepare this Excel sheet. Okay, first you understand the concept. The breadth is 2.6 meter, it's written here, and this is overall depth, that is capital D. This is the overall depth of your footing. Okay, this is the overall depth of your footing, which is capital D, which is written 0.6, and this is small d, this much portion, the rectangular portion, whatever you have, no, this is your small d. I've written it as 0.35. Now I want this height. Okay, this particular height I want. Okay, so how do you find this height? Very simple. This overall depth, 0.6 minus 0.35 will give me this height. Okay, and this is actually h. Instead of this, I'll write h here. Now h, I'll tell you what exact. So this is called as h. Okay, if you want, you can write h here. So this portion is called as small h. Okay, this portion is called as small h. This much is understood? Fine. So once you understood this much part, next we'll try to find the PCC quantity. How we are going to find the PCC quantity? Very simple. The footing length is given, that is 3.8 meter. I'll take 75 offset on the left side, 75 on the right side. Very simple. Okay. So again, same thing I've written it here. See, PCC I've written here. Okay. I'll do it here. Equal to sign. What is this thing length? Length is 3.8 plus on the left side, I'll take a PCC offset of 75 So I return it here 0.075 plus again 0.075. Okay, plus again 0.075. You can do it manually. You will get 3.95 PCC length one side. Breadth again it is 2.6. Again 0.075 on the right side, 0.075 on the left side. So again you see here that is 2.6 plus 0.075 plus 0.075 you do, you'll get 2.75. Now total PCC quantity will be how much? The length multiplied by the breadth, that is 2.75, into the thickness of the PCC. So this thickness of the PCC I'm considering 100 I've taken 100 here. Okay, if you want I'll do it for you. because PCC quantity is same thing. Okay, there is no change whether it is isolated, combined footing, or whatever it may be. It's 1.09 cubic meter. That doesn't matter. Now the important portion is about the concrete quantity for this particular footing. Now this particular footing, what I have, I'll break it into two pieces. That means I'll break this into one. This portion is my rectangular portion. This is my rectangular portion. Okay, and then after that, whatever is remaining, no, this portion, whatever is remaining, that is my trapezoidal portion. Okay, first I'll find the concrete quantity for the rectangular portion, and then I'll try to find that concrete quantity for the trapezoidal portion. Is it clear? Okay, chalo. We'll start with this now. Okay, so first, how do you find the concrete quantity for a rectangular portion? Very simple. Whatever is my length of my footing, I'll multiply that by the breadth of the footing, and that I'll multiply by the depth of this particular thing. Okay, so you can see a rectangular portion RCC, I've written it here, which is equal to, I'll make it here also, equal to, what is the length of your footing? 3.8. What is the breadth of your footing? 2.6. And what is the depth? Depth is, it's not the overall depth, you have to take only the rectangular portion depth. How much it is? 0.35. So 0.35 is here. I'll click on this. So I'm getting 3.45 cubic meter. Okay, if I detect this, 3.46 cubic meter. This is only the rectangular portion. Again, the trapezoidal portion is left out. Now for the trapezoidal portion, you have to use this formula. So note down this formula. The formula is h by 3 multiply by, see how I'll do. Yeah, how I'm going to do this? The h by 3. What is h? This is h. Okay, h already I got 0.6 minus 0.35. I'll get this h. So this h I got. Okay, multiply this by AB. AB in the sense bottom area. What is my bottom area? This is my bottom area, isn't it? This is my breadth side area, bottom area. Okay, this is my bottom area. Okay, this is my bottom area. And plus A at T, that is top area. This is my top area. I'll show you here. See, this is my bottom area, this much part, bottom area. Okay, and this is my top area. Understood? Okay, so I written AB is bottom area. Okay, A is area, BA, that is bottom area, plus top area, plus square root of or under root of AB. AB means again bottom area. This AB is bottom area, and you plus top area. It is top area. Okay, this much is understood. Now first we'll try to find the bottom area. Bottom area is very simple, because this length already I know. What is this length? This length is actually the footing length. Very simple. This length is footing length. So AB is equal to bottom area. How I'm going to find? 3.8. So this is 3.8 on this side. Multiply this by 2.6 on the other side also. See, if you're getting confusion, what I'll do is I'll take one image from here. Control C. I'll bring this image here. Okay. Now all your confusion will be gone. Yeah, and I'll keep it here. First I'm finding the bottom area. Okay. So this bottom area, AB, yeah. So it is 3.8 into 2.6. That means this is 3.8 and this is 2.6. If I multiply this, I'll get the bottom area. So AB is your bottom area. Got it? So multiply this 3.8 into 2.6 will give me 9.88. 9.88. Okay. Next is I told top area. What is the top area? This is my top area. Okay. This is my top area. That means I want to find this area now. This area we can see. This area I want. Okay. So to find that top area, I want T. The formula is top length into top bottom. That means top length, top along the length side, and top along the breadth side. That means I require this one. See here. This is that portion. This length and this portion I require. I'll do it here. I want this length. I want this portion. Okay, and I want this portion length. Okay, if I multiply this both, I'll get my top area. Okay, how we are going to do that? That is small trick in that. So right now this particular portion is your column. Okay, and what is the dimension of the column? It is given. This is 0.5, that is 500 mm, this one, and this is your 400 mm. Okay, that is a column dimension. But I want this entire thing, no? So that is why this offset is given. This is your column. Okay, so from here, from your column outer to this part, it is 75 mm, that is 0.075, and from here to here it is 0.075. Okay, so if I add 0.5, if I add this, that is 0.075, plus 0.5 plus 0.075. Am I not going to get this entire length here? Or length part I'm going to get? The same thing I've done it here. That is top length is 0.075, this one, plus 0.5. From where I got this 0.5? This one, this portion. Okay. I'm doing this side now. That is column this side. So 0.5 plus 0.075. So add everything, you'll get 0.65. So one side I did now. This length side I did. This side also I have, no? This side also I am supposed to do. Again, I'll follow the same thing. This side also I'll do the same thing. That is top breadth side. TB means top breadth side, and TL means top length side. Okay. So again this portion is 0.075. From here to here it is 0.075. And what is the column dimension? 400 mm, zero point 0.4. And from here to here again it is 75 mm. See, this is a cross section. In this you're going to get only one side, not both the side. Okay. So even if you want to get it more clear, it will be here. See, right now whatever I had done, no, I did only for one side. I did this one. This was my 75. Yeah, this was 75. Okay. After that, I had this column dimension of 500. Okay. And then I had this 75. This much is understood. Length side I did. In the same way, breadth side also I want to do. Again here, this will be 75. Breadth side, your column dimension was 400 mm. This will be my 400 mm. And then again 75. You're getting my point. And now if I multiply this portion into this portion, am I not going to get the complete area of the top side? Obviously I'm going to get the same thing. I'm trying to do it here. Okay, see now 0.075 plus 0.4 plus 0.075, you'll get 0.55. That's it. So once you get this, your task is done. Now you just have to input this in the formula. Now the formula says h by 3. What is h? H is this distance. This is your h distance. How much it was? H was here 0.25, that is 0.6 minus 0.35. You put this formula. Already I've done that, but still I'll do it again. So the formula you have to follow this. Okay, this particular open bracket close bracket you have to follow. Only then you'll get the answer. Equal to sign, I'll open the bracket. Okay, h I'll take from here 0.25. I'll divide it by 3, h by 3. Okay, and then close the bracket, and then use this multiplication symbol star, and then again 2 times open the bracket. So this is called AB. AB is the area, right? So AB is your area. So what is the area you got in the bottom? 9.88. I'll select this 9.88 plus top area. 80 is top area. Top area, how much you got? So top area, yeah, top area, how much I got? I should add this, no? For top area, that is 0.66 into 0.55. It will be 0.36. You add this. Okay, you multiply 0.65 into 0.55, because for top area I want to multiply the top length, that is top length into top breadth, that is 0.65, and 0.55 you multiply, you'll get 0.66. You'll get 0.36. I'll take this 0.36. Okay, now again I'll close the bracket, plus now square root you should write in your keyboard SQRT, right? The square root will pop up. Okay, so once you write the square root, then again open the bracket. Again AB, that is a bottom area. Okay, it is 9.88. Close the bracket, plus open the bracket. Again top area is 0.36. Okay, then again close the bracket, and 2 times you close the bracket and hit the enter button. So I'm getting 1 point. Okay, this time I'm getting 1.14. No, I should get 1.01. Okay, not 1.14. If I do it manual also, I'm getting 1.01. So maybe somewhere we have done a mistake. We'll rectify that, no problem. I'll do it manually once. Let me check it out. Okay, h by 3. So h is 0.25 divided by 3. Then I'll multiply this by 9.88 into 0.36. I'll close the bracket, plus under root of, plus square root of, I'll open the bracket, AB, that is a top area 9.88, plus, sorry, bottom area plus top area. Top area is 0.36. Close the bracket. Let me check it once again, because 1 point, see here I've done it correctly. See, F6. Okay. So let me check both the formula, what is wrong. So 1 open bracket, here also it is open bracket, divide by 3, I've done, close bracket, multiplication, open bracket, double open bracket, C20, plus D23 plus D23 plus square root plus square root. Okay, here we have done this mistake. C20. Okay, now it should come. See, C20 into D23. C20 C20. Let me check the formula. Just give me a minute, okay? Because in Excel sheet, yeah, this formula I written, this should be multiplication. Sorry for that. This is multiplication. I checked it now. Okay. Yeah, this is multiplication. Okay. So now you do it proper. This should have been multiplication and not the addition. Multiplication. Yeah, now it's coming correct. See, 320, 320, and this bracket is not required. Bracket you close. Yeah, and then uh, 2 open bracket. So here also you require 2 open bracket. Yeah, 1.0. This if I try to minimize, no, exactly. You're getting, see, trapezoidal portion I got 1.01 cubic meter of a concrete. So total concrete will be how much? The total concrete will be my rectangular portion plus my trapezoidal portion. So that is rectangular portion, how much I got? Rectangular portion concrete was 3.46. So 3.46 plus 1.01 will give you 4.47 cubic meter of a concrete. Very simple. Now coming to the shuttering quantity. Shuttering is very simple, because if I show you the image again, see, shuttering where you do, wherever shuttering you don't do on the top, like you did it normal, this length, the perimeter you multiply, this entire perimeter, and then you multiply this by the depth of the shuttering or the depth of the footing, you'll get the shuttering quantity. That means you can directly take like equal to sign. What is my this thing? I'll do it here only. Okay, it's easy for me. Shuttering, I'll do it here. Okay, equal to sign. My length is 3.8 plus 2.6 plus 3.8 plus 2.6. Okay, so you multiply this by, I'll close this. This I'll open. Yeah, this I'll multiply by the depth. So depth is how much? Footing depth. Footing depth will be how much? 0.35. Why not 0.6? Because shuttering will do only up to rectangular portion. So you have to take 0.35 and enter. 3.78. Wait. Into the depth. Yeah, this answer into E6. So I should get 4.48. Why I'm getting 3.78 here? So length is 3.8, breadth is 2.6. So B6, B6, the C6. Yeah, we should get the answer. Why it's not happening? Let me recheck it. Okay, no problem. See, don't get worried. When you encounter such problems, only you'll learn all these things. See, what I'm trying to tell is perimeter will be 3.8 plus 2.6 plus 2.6 plus 3.8 perimeter. We'll multiply this by the depth. So depth is 0.35, right? We'll do that. I'll do manually. We'll see what will happen. 3.8 plus 3.8 plus 2.6 plus 2.6. Let me know how much answer we are getting for this. So 3.8 plus 3.8 plus 2.6 plus 2.6. So I'm getting 12.8. Okay, 12.8 is perimeter. I'll multiply this by depth. Depth is 0.35. Multiply this by 0.35. 4.48. Exactly. I should get 4.48 square meter. And why is that I'm getting 3.78 in this case? Let me recheck this. Maybe because of the BODMAS formula, it will take that, B6 plus C6, B6. Okay, 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 fine. See, one mistake we have done. Why? B6, this is correct. Okay, see, this B6 indicates this B column and 6 row. Okay, B6. Then again C6, 2.6. Then again I took B6. But next I took D6. I took 0.6 here. Hmm. So that is why that error was coming. So I should take 2.6. Now the answer should come. Not the problem with the board mass. You can close the bracket. You'll definitely get the answer. Exactly. See, 4.48, 4.48. Got it? So this is how you're supposed to do the shuttering quantity, concrete quantity for the trapezoidal footing. Okay. I hope you have enjoyed this lecture. You got an idea how it has to be done. So what I'm going to do is, in the next lecture, I'll teach you how to prepare the Excel sheet for the trapezoidal footing so that you can use it in your projects. If you prepare one Excel sheet and keep it for any of the footing I give you, you can directly get your answer within seconds. So in the next lecture, I'll teach you how to prepare a beautiful Excel sheet for this so that we can use it anytime. Okay. We'll see you back in the next lecture. Thank you.